Very warm welcome to everyone, and this is Viranjana Reddy, and today we'll be demonstrating about the banker's algorithm. Basically, in an operating system, a deadlock occurs when two or more processors are stuck waiting for resources held by each other. For example, imagine we have two processors and two resources P1, P2, and R1, R2, while P1 is holding the resource R1 waiting for R2, while process P2 is holding R2 and waiting for R1. Neither can continue. This situation is called a deadlock. To handle this, we use deadlock avoidance techniques, and one of the most famous is the banker's algorithm. The banker's algorithm works just like a banker who gives loan, only if he is sure all customers can eventually repay. Similarly, the system rechecks whether granting a resource will keep it in safe state. If yes, it allocates the resource. If not, the process must wait. This ensures that the system never enters an unsafe or deadlock state, maintaining a smooth and safe resource allocation in multitasking environments. Let us have a look over this example. Imagine you walk into a bank asking for a loan. The banker doesn't just hand out the money. The first check if giving you that loan would leave the bank in the safe state, right? Now, what if I told you that operating system works in the same way? In world of process and resources, the OS acts as a smart banker. Every process is like a customer requesting resources. The banker's algorithm steps in to check. If I grant this request, will the system stay safe or will it slip into a deadlock? A situation where no one gets what they want. If the state is safe, the request is approved. If it's unsafe, if it's denied. Just like the real banker deciding who gets the loan. Through this interactive learning showcase, we'll show how this algorithm ensures safe resource allocation and keeps the system running smoothly, proving that even in a computing, a little financial wisdom can save us from a. And I hereby asking Sayashif to continue.
These are the advantages and disadvantages of banker log algorithm system, and some of them are: it contains various resources that meet the requirements of each process, means there are various resources to each process can be allocated. The main disadvantages is the fixed number of process and no additional process can be started in the system while executing the process. This is the banker's algorithm code in which we are using Python script, and we are imported Tinkler for GUI use, and we have made a class named banker's algorithm to get the banker's algorithm steps. These are the GUI steps we are followed, and we also created some functions called create matrix, in which matrix is created, and for allocation, max, and availability and need, four things which are required for uh, achieving or crossing deadlock condition. And we have done another uh, function called run simulation, in which the whole code will be executed by a matrix thing to decide the condition is safe or unsafe. And we have done another function called check safe sequence, in which the check safe sequence is executed here. And we have done three three main functions which are used to highlight process and update availability colors and resource requests. And another function is created to submit the request and register that the request is declined or approved, or also known as safe or unsafe. And this is the whole GUI concept we have introduced. So let's execute it. In graphics user interface, we can see that we have added created by me and my teammates name, and we have mainly defined two user input models, in which number of process is 3 by default, which is used in the code. We can also change it by using other thing. We have also added number of resource 3, which is same as a by default in code. We can have a different number also. So by executing it to a set matrix, by adding some inputs in it, we can do. For allocating matrix, we have to input the allocation memory. So for we can further do it. For matrix max matrix, we have to also do the same process. So how many intervals we can do the matrix. As you can see, the error is pop out that the system is not in a safe state, because there is a very safe sequence which is given, which is P1 is using first, and then P0 is using, and P2. So it's not acquiring any of the logic, so it's giving a rollback error, which is gives the result not safe, or also known as unsafe.